should say parametric equations. Do you see a screen that says parametric equation?
Can, Doctor.
Yeah. Okay, great. Thank you. Okay, so again, for those of you who just joined, welcome to Calculus 2. Okay, so what Calculus 2 is, okay, let me just write it down here. So what? Ooh. Okay, so what Calculus 2 is, Calculus 2 is actually a continuation of Calculus 1. Okay, so I believe everyone's done Calculus 1. I'm not sure how many failed Calculus 1, but hopefully no one failed. Okay, and so Calculus 2 is continuation of Calculus 1. So what that means is everything you've learned in Calculus 1, well, most, yeah, not everything, but most of the things that you learn in Calculus 1, you have to apply in Calculus 2, this course. All right. So because of that, I advise you to go back and do revision on Calculus 1. Okay? Because whatever I'm teaching you in Calculus 2 is actually nothing new. Okay? It's actually nothing new. A lot of them are literally just extension of Calculus 1 topics. All right? So historically, when I look back on the student performance, most of people who didn't do well in this course, Calculus 2, most people who didn't do well here are the people who struggle with Calculus 1 originally. Okay, so your foundation is very important. Okay, if your foundation is solid, you will not have any issues in Calculus 2 here. Okay, I'll give a very quick example later. Okay, I'll tell you why very quickly later. Okay, why Calculus 2 is actually very similar to Calculus 1. Okay. Right. Okay. So before I go further, I will maybe do a bit of introduction to the course in terms of the mark structure. All right. So in terms of marking, what type of marking structure do you have in Calculus 1? I mean the split. Carry marks and final exam. What's the split between carry marks and final exam? Do you still remember? Calculus 1. Calculus 1, what is a split? Can someone tell me? Carry marks, how many percent? Do you still remember?
60.
60, yeah? And then final exam, 40. Okay. So, okay, that's good. That's good because for Calculus 2, it's also the same. Okay. For Calculus 2, your carry marks will be 60% as well. And final exam will be 40%. All right. So it's the same now. Okay. Same as Calculus 1. All right. So let's talk about the carry marks first. So the carry marks 60% will comprise of 4 tests. No assignments. So no assignments at all for calculus. Okay, only test. No midterm, no assignments, only test, and no quiz either. Okay, test 1, test 2, test 3, and test 4. Okay, so each one will carry 15%. Okay, each one will carry 15%. As for the final exam, it's 40%. So what that means is, for the final exam, you will get 4 questions in the final exam. Question 1, question 2, question 3, and question 4. Okay, so each question will carry 10%. Okay, so each question will carry 10%. Okay, so that's the mark distribution. Okay, now how many topics are we covering? So next I'm going to go. Hey, any question on the carry marks and final exam?
No, doctor.
Okay, all right. So if there are no questions on this, I'm going to go through each topic very quickly. Okay, so how many topics are we covering here in calculus 2? How many topics did you cover in calculus 1? Still remember? How many topics in calculus 1?
Five, doctor.
Or 5, huh? Yeah. So okay, so you covered
Four,
you
doctor.
covered
Okay.
4, 5. Did I 4? Okay, just 4. Okay, just 4. So okay, so this is probably where there's a small difference between calculus. Let me see. Okay, so originally, calculus 2, we normally cover 5 topics. Okay, we normally cover 5 topics. Topic 1 is parametric equation. Topic 2, okay, let me talk about what parametric equation is. Okay, so topic 1 is parametric equation. So what parametric equation is, it's basically like your coordinate, the XY coordinate system, your Cartesian coordinate system, X and Y. Okay, I plot a line or something. Okay, this is your normal Cartesian equation, X and Y. Okay, so how many variables do we have here? You have 2 gun, X and Y gun, so 2 variables. Okay, so what parametric equation will be doing is, okay, it will introduce a third equation. Okay, that third equation, normally I call it T. I will look at it in terms of time. Okay, I will put a third dimension on things. All right, so that's literally parametric equation. So it's basically your XY Cartesian coordinate topic with 1 more variables. That's it. Okay, so that's why it's very important for you to be familiar with your X and Y, how to draw a line function, how to draw a U-shaped function, how to draw, okay, this type of function, okay, things like that. All right. So, but your basic in your Cartesian equation has to be solid. Then you will be you will not have any problems for this topic. All right. Now the second topic is polar coordinates. Not sure whether you heard of this before. Okay, polar coordinates. So polar coordinates is basically, your, again, it's related to your X and Y. Okay, it's related to your X and Y Cartesian system. So normally if you have in the X and Y Cartesian system, you can use it to call up a coordinate gun somewhere here. Okay, I can say, oh, this coordinate is what? You call it up in terms of X and Y coordinate, right? So if this is 3, this is 2, then what is the coordinate here of that point? What is the coordinate of that point?
3, 2.
Yeah, 3, 2. Okay, so this is using your normal Cartesian system of calling up that coordinate system. Okay, now in polar coordinates, what we do is we use angle and distance. Okay, we use angle and distance. So we have angle of 0 degrees. We have angle of 90 degrees. We have angle of 180 degrees. We have angle of 270 degrees. Okay. So if you look at this angle system, 0, 90 degrees, 180, 270, it's actually very similar to X and Y coordinate you got. Okay. So what you can do is you can actually represent this 3, 2 there. You can represent this 3, 2 there. But the way you call it out will be different because here it's not X and Y coordinate. Here, yeah, this one here is not called X and Y coordinate. It's in terms of angle. Okay, so the way you call it up, you call up this coordinate in this format is you draw a line from the center. We call it the origin to that point. You measure that angle. And next, you measure the distance of that line. So the coordinate of that line is that distance r and that angle theta. Okay. So and then you will be taught how to convert between the two. You can convert between the two. Okay. So that's polar coordinates. Second topic. Third topic, vectors. Okay. Don't know whether you've done vectors before. Okay, vectors is basically you use vectors to define the movement, okay, of a line. Like that. It looks like that. Don't know whether you've seen it before, vectors. Pernah buat vectors kah? Okay. If you haven't, don't worry. I will give you a crash course in it. All right. So third topic is vectors. Fourth topic is what do they call it? Differentials. Okay, fourth topic is differentials. Differentials is basically differentiation. So again, differentiation, you've done it before. You've done it in calculus 1. Okay. You've done maybe dy, dx. Okay. So dy, dx, how many variables do you have? 2 kan? Y and x. Yeah, 2 variables, y and x. Okay. So what we are doing here is in calculus 2, we are going to introduce one more variable, maybe a z variable. Okay. So that's why you see everything here is related to calculus 1. Okay, everything here is related to calculus 1. In calculus 1, you do dy dx. So here, I'm going to introduce another variable, z variable. So you have to differentiate 3 variables in essence. Okay, so the last topic is multiple integrals. So as you can imagine, it's integration. Okay, integration. Okay, so again, last time when you integrate only 2 variables. So here you're gonna be multiplying multiple integrals. So you integrate multiple times. That's it. Last time you only integrate once. This time here, maybe you have to integrate 2 or 3 times. So that's it. Okay. So again, the basic is important. Okay. If you have the basic in, you will not have any problems here. All right. Okay. So we are going to, so with that out of the way, I think we can start with our first topic today. Okay. So the third topic, so the first topic is parametric equation. Okay. So, okay. So as I'm speaking here, I want you to take your own notes. Okay. You have to take your own notes. First of all, because this video will not be recorded. Okay. The video will not be recorded. I'm not recording it because I want everyone to pay attention when I'm speaking. Okay. So no recordings. Secondly, my notes, these notes that I'm writing here, I will not share with you. Okay. I'm not going to share my note with you. So you have to take your own notes. Okay. Now, during the class, if you don't understand anything, you can stop me straight away. Okay. So I'll say that again. During the class, as I'm teaching, if you don't understand anything, you have to unmute your mic and ask me straight away. Don't wait. Okay. You don't understand anything, you unmute your mic and you ask me straight away. Do not wait. If you wait, you will forget what you want to ask me. Okay. So kalau ada apa-apa soalan, you can unmute your mic, terus tanya saya. Okay. Jangan tunggu. All right. So first topic, parametric equation. So what is parametric equation? So I've gone through it very quickly with you, studied what parametric equation is. Now I'm going to go through a bit more detail. Okay. So for you to be successful in this topic, you need to know the most important skill is how to plot x and y equation. Okay. The most important thing is you know how to plot x and y equation. So let me test you. Let me test you. Okay. So you have your normal x and y. If I have a curve like that, what is the formula for that curve? Anyone? Okay, if it's a straight line, then why is it? If it's a straight line.
YMX plus C.
Yeah. Okay. Now, this y equals to what? X.
AX square plus
Y,
bx plus c.
yeah, y equals, well, to simplify it's y equals to x squared. Okay? To simplify, it's y equals to x squared. If it's like that, y equals to what?
Negative x squared.
Yeah. Okay. So if I have a plus c, what does the c stand for? It's normally the c is the y-intercept, right? Correct. C is the y-intercept. For example, here. For example, for this straight line here, y equals to mx plus c. That c is the y-intercept as well. So it means your line, your straight line, wherever it hits that y-axis, your line, wherever it hits that y-axis, if it hits the y-axis at y equals to 2, that means C is berapa? 2. Correct. Yeah. Okay. So no matter what your equation is, that C will always be the y-intercept. So wherever your curve hits the y-axis, that's the C. All right. So for this course, you need to be able to identify these shapes very quickly, okay? And need to know the equation related to it. Okay, so okay, so that's one thing about this course. So next is, how is this course different from your normal X and Y Cartesian coordinate course? Okay, so as I mentioned earlier, okay, let me go straight here. Okay, so again, X, Y. Okay, let's do an easy one. Let's do a straight line. Okay, perhaps let's do a straight line. Okay. So let's say I have a straight line here. Okay. So when I have a straight line here, you know this curve is y equals to mx plus c. Okay. You know this line is the equation of the this line is y equals to mx plus c. Okay. Now, if I tell you at any time, if I tell you I want you to find the coordinate at that point, are you able to look for it? You can, right? You just draw a line down, you get the x value, you draw another line horizontally, you get the y value, correct? Okay, so this is what you learned previously. All right? You learn how to create the equation for this line. You learn how to get coordinates on different points of this line. But there's one thing you didn't learn, or rather you haven't been taught. Okay, what if, or rather, this line doesn't tell you one thing. This line at the moment, no direction. Okay, this line has no direction. Do you agree? There's no direction, right? Okay, can I ask you? Let me ask you. This line, this red color line, is it going from left to right, or is it going from right to left? Can you tell?
Not stated.
It's not stated. Correct. Direction not stated. So you don't know. You don't know the direction. It's not stated. So you don't know whether this line is going from left to right car or right to left car, up to down to up, you don't know. Okay, because all it is a line. There's no direction. Okay, so so what we are doing in calculus 2 is literally we are going to put a direction into this line. Okay, we are going to put a direction into this line. So to introduce a direction into this line, you are going to need a third variable. Okay, so dulu, so last time you have x and y. Now what you're going to do is you're going to introduce a new variable t, the time. Okay. Okay, so you're going to introduce a new variable t, which is the time. Okay. So why is this important? Why do you need to know direction? Well, it's important because imagine if this line is representing the aircraft flight path from KK to, let's say, KL. Okay, so let's say this line represents the flight path of an aircraft that is flying between KK and KL. Okay, so then so if you don't have direction, you don't know whether it's going from KK to KL or from KL to KK. You don't know which direction it's going. Yeah, dia terbang dari KK pergi KL or dia terbang dari KL pergi KK. You don't know. Okay, so that's why we need a third variable called time. Then we will be able to tell the direction of the travel. Okay, so first of all, I'm going to introduce some terminology. Okay, so I'm going to introduce some terminology. Okay, so same thing. So same thing. We have a straight line equation. Okay, we have straight line equation. So let's say this line is going from right to left. Okay, it's going this direction. So you're gonna have to put an arrow, obviously, okay, to note the direction. So if it's going from right to left, that means the right hand side is the starting point. Okay, the right hand side is the starting point, which means normally for a starting point, we call it initial point. Okay, normally for the starting point, we call it the initial point, and the initial point t is equals to 0. Okay, because you start there, because imagine if you're driving from I don't know, from Ladatu to KK. Okay, so this is Ladatu and the other side is KK. Okay, so when you're traveling from Ladatu to KK, you want to take time. Obviously, you start from time equals to 0. Okay, so that later when you arrive in KK, you take another time, and that's your arrival time. Okay, so you start at initial point, time equals to 0. Okay, next, when you arrive in KK, that's where you finish the trip. So we call it the end point, we call it the terminal point. Okay, the end point, we call it the terminal point. You can call it end point as well. When you're answering question in test and exam, you can call it endpoint as well. No problem. Okay. So starting point we call it initial point. The finishing point we call it the terminal point or the endpoint. Okay. So the endpoint is gonna have another time. I don't know, maybe time equals to 10K or 20 or 30. Okay, depending on how long it takes for you to travel. Okay. Okay, so in a normal Cartesian function, okay, so in a normal Cartesian function, what you normally have is this type of function, or you may have this. Okay, doesn't matter. Or you may even have this. Okay, y equals to x, y equals to x squared, y equals to x cubed, doesn't matter. Okay, but no matter what they are normal functions. Okay, and the characteristics of all of this is that y is related to x. That's the important point. Y is related to x in all these functions. Okay, y is always related to x. Okay, now this is normal. This is the normal Cartesian function. Now, for this course, parametric equation, in a parametric equation, so as I said before, in a parametric equation, we are going to introduce a new function, namely t. Okay, it can be small t, it can be small t, it can be big T. Okay, doesn't matter. Okay, but we are going to introduce a new function. Sometimes I use small t, sometimes I will use a big T, but it doesn't matter. Okay, if they both mean the same thing. Okay, so how does that fit in? How does that fit in our current equation now? Okay, because our current equation, in our current equation, y is related to x. Okay, in our current system, y is equals related to x. Now we want to put a t in. How do we put a t in? How do we put a t in so that t is related to y, t also related to x, and y still related to x? How do you do that? So x, y, and t has to be related to each other. Okay, so the way we do that is like that. What we do is we take the y out, we take the x out, we do a new equation where y is now a function of t. We do a second equation where x is also a function of t. So maksudnya y equals to, I don't know, t squared plus 3, something like that. Example, this example. This is example. Yeah. So when I say y is a function of t, what I mean is y is equals to t squared plus t, something like that lah. Okay, something like that. Okay, and when I say x is equals to function of t, what I mean is you're gonna get an example of x equals to t plus 2, something like that. Example. Okay, but the point is you can see now. The important point is y is related to t, x is related to t. That's the important point. Okay. So if you are able to relate y with t, x with t, t and t here, t on the left and t on the right is actually the same t. Okay, so they are both x and y is both x and y is related to the same t. Okay, so that means all of them are related, interrelated together now. Okay, so what you can do is you can use this to define motion. Okay, use this to define motion in both x and y. As a function of variable t. Okay, over over a common domain. I will tell you what this means later. Okay, over a common domain I. All right. So t here is parameter. I is the domain or the interval. Okay. Any questions up to this point? Are you guys still following?
Yes, doctor.
Okay. So if there are no questions, normally in my courses, okay, so normally in my courses, I don't go through a lot of theory. Okay, I go through a bit of theory and then I go straight into the examples. Okay, because by doing examples, then you can understand better what is actually going on, what I'm talking about. Okay, so if there are no questions, I'm gonna jump straight into one example. All right. Hopefully you can understand better when I go through the example. All right. Right. Okay. Example. So let's say I have an example here. X equals to t squared minus 4. Y equals to 2t. Yeah, sorry. Okay, so x equals to t squared minus 4. Y equals to 2t. And then the interval is this. So basically what the interval is, so the interval is, it basically sets a limit. The interval basically is a limit for the t value. Okay, for the t value. It will tell you the t starts from, so the t here starts from -1 and finishes at 2, positive 2. Okay, so you can see here, t has to be larger or equals to -1. T has to be smaller or equals to positive 2. So what that means is any value between -1 and 2 is valid for t. Okay, That is basically what the interval is. Okay, it basically gives you a range of values for the t. Okay, t values. All right. Okay. So first question is, simple one, is this a parametric equation? Okay, because later on you may have to learn how to convert between the two, from Cartesian to parametric, from parametric back to Cartesian. You need to convert between the two. Okay, so that's why you need to recognize whether this is Cartesian or this is parametric, so that you don't do your conversion the wrong way. Okay, so is this parametric or is this Cartesian? If it's Cartesian, x will be directly related to y. Also, sorry, or rather, y will be directly related to x. To x. Okay, if it's Cartesian, yeah, x. So y will be directly related to x. Now, in my question, x related to what? X is related to what?
T.
T.
Y related to what?
T.
Yeah. So, Cartesian or parametric?
Parametric.
Yeah, parametric, yeah. So is this a parametric equation? So the answer is yes. Because x related to y, sorry, x related to t, y also related to t. Okay? And x and y is not directly related. Okay, so I'm saying here x and y not directly related. They are related, but through t. Okay, so they are related, but only through t. Okay, not directly, indirectly. They are indirectly related to each other, x and y. Okay. So, second question, I would ask you to plot the function. Okay. Second question is, I will ask you to plot the function. So how do you plot the function? So basically now, what I'm saying is, I want you to plot this on a graph. How do you plot this on a graph? Okay, normally when x and y, how do you plot the line x and y? You get the coordinates kan? You need to get the x and y coordinates. Betul tak? So let's say I have x and y coordinate. I don't know. 0, 0, 1. Where is 0, 1? Sini kan? And then 2, 3. Where is 2, 3? 2, 3 will be here and up there. There. Yeah. So the point is you always get x and y coordinate. If I have the point here, I have another point here, and then maybe I have another coordinate, I don't know, somewhere up there. Then can I plot or not? Then I can join the line. And then I get my function, correct? You know this method, right? Do you know this method?
Yes.
You find the x and y, and then you plot the x and y, and then you join the dots together. Yeah, then you basically get a function. Okay, so this is how you used to do it. So here, how do you do it? Here, can you get x and y kah? Boleh. Why not? X is related to t. Y is related to t. The t is actually given to you. T is actually given. T is between -1 and 2. So what you do is you draw a table. Of t. So t goes from -1. Then maybe we do a -½ Then maybe we do 0. Then maybe we do half. Then maybe we do 1. Maybe we do 1.5. No need, no need 1.5. We go straight to 2. Okay, so t here basically is from -1 to 2. You can put more points. You can put more points in the middle than your curve. If this is a curve, the more points you have, the more accurate your curve will look. Okay, but in my case, actually this is a curve. Yeah, in my case, this is a curve, but I don't want to draw so many points lah, lazy. Okay, so I think this is enough. Okay, so we know our t goes from -1 to 2. Okay, so then can we get x and y out of this? Then you just substitute your t in. So when t is -1, what is x? Tell me. You do it and tell me. Quick. Substitute the -1 into x into the x equation.
-3.
Yeah. And what's y?
-4.
Huh?
-2.
-2. Yeah. Okay. Okay. Good. Okay. Someone else this time. When t is -½ what is the x and y? Make sure you can do this. This is very easy. You basically just substitute into x and y your t's. When it's half, what is it? Okay, it's -15/4. Okay, and y is -1. Okay, y is simpler. Okay, so when t is equal to 0, what is x and y? Yep, -4. And y? 0. Okay. Okay, so half, I will do half. So when t is equals to half, x is -15/4, just like when it's -½ okay, because of the negative in front. Okay, and then y is going to be 1. Okay, and then this is -3, 2. This is 0, 4. Okay, so there. Now we have the points. Now that you have the points, can you plot? Boleh kan? Now that you have the points, can you plot the points on x and y? Yeah. So plot you so do it yourself as well. You have a sheet of you if you are taking notes on a sheet of paper, then make sure you draw everything to scale. Okay, make sure you draw everything to scale. All right. Okay, so when t is -1, we know we have x is equals to -3, y is equals to negative. So y is -2. Okay, so negative So x is equals to -3, maybe somewhere there. And then y is equals to -2, somewhere there. So our point is there. Okay, that is the first point. Okay, first point. or rather, that is where t is equals to -1. Okay, that is where t is equals to -1. Okay, the second point, when t is -half, it's -15/4. -15/4 is what? 15 divided by 4 is what?
3.75.
Okay, 3.75. Okay, so 3.75 means somewhere here. And then y is -1. So there. So there. So that is when t is -half. Okay. Okay, next. When t is equals to 0, we have 4, 0. So 4 is here. And 0 is on the means it's on our x-axis. Okay. So this is where t is equals to 0. So that's your third point. Where is your fourth point? It's -15/4, but +1 this time. That means it's up here somewhere lah. And then the fifth point, when t is equals to 1, is -3, 2. -3, +2 is roughly there. So that's when t is equals to 1. And finally, when t is equals to 2, is 0, 4. 0, 4. Somewhere. Okay, so now you have all the points. Can you join all the points together? Okay, so I'm going to use a different color. I'm going to use green. Tak apalah, use red. I continue using red. So if you join everything up together, what you end up with is basically, it's very difficult to draw on my screen. Okay, it's basically a curve like that. That's what you get. Okay. So that's your function now. Okay, the curve. Now, have I finished answering? No. Okay. So if you leave your answer like this in the test and exam, you will get only half the marks. Okay, because something is missing. Okay, I'll tell you what's missing. Now, so the whole point, so the entire point of this course is so that we have the line. Let me go back here. At the beginning. So see, this is the entire point of this course. We have the line that is joining Lahadatul with Keke. But we have another thing. We have that arrow there. What is that arrow? Direction. Kan? Yeah, we have that arrow. That arrow tells me the direction. What else do we have here? Apa ni?
Initial point.
Yeah, we have the initial point. We have the end point. Okay. So you need to. So in your answer, when you're answering this question in test or exam, after you've drawn the line, it's not enough. You need to tell me the direction and also the end point and starting point. Okay. So the initial point is basically the one where you begin lah. This one. Yeah. Yeah. The one with the lowest t. Okay. Because you start your journey when t is 0 ma. Okay, or when t is less than 0 sometimes. Okay, so this is the initial point. The other end is the terminal point. Okay, So what that means is t equals to -1 is the initial point. So you have to write this down in your test and exam. That's your initial point. And t equals to 2 is your terminal point or your end point. Okay, so now that you know your initial point, you know your end point. Okay, do you know which arrow? Do you know which direction the arrow is supposed to be pointing? You can draw the arrow now, kan? Yeah, it's basically pointing. Okay, it's basically pointing that direction. Okay, so now your answer is complete. Now your answer is complete. Any questions? Any questions about this? Okay. All right. Okay. Okay. Now, this is one way. This is one way of answering this question. There's actually a second method of answering this question. I'll show you the second method. I'll show you the second method of answering this question. So in some cases, it's very time consuming to draw this table. Yeah, if you imagine, if you have to draw this table, you have to put all the t's in, and then you have to calculate the x and y for every t. Yeah, you have to calculate the x and y for every t. It takes a lot of time. Okay, in my case, okay lah, the example is simple, so that's why your table is a small table. But in some cases, your table can be a very big table, very long table. Okay, and it can take a lot of time. So there's another way, which I think is the shorter way. It's a shorter way of you to get the same answer, basically. Okay, so the shorter way is this. So you know x. So we know x is equals to this. We know y is equals to this. Okay, can we substitute into each other? We can combine. What we can do here is we can combine both parametric equation into just a purely x and y function. And we remove the t. Okay, what you can do here is you can combine both the parametric equations into a x and y function, and at the same time you eliminate the t. Okay, so I'll show you how this is done. So we know. So we start with the. We start with the. We probably want to start with the simpler parametric equation, which is the y. The y looks simpler. The x, there's a kuasa dua sana. Okay, so the x is a bit more tricky. So we start with the y first. We know y is very simple. Y equals to 2t. Okay, y equals to 2t. Can you rearrange this to get t? What is t if I rearrange? What is t? Yeah, y over 2. So t is y over 2. Okay. So now that you know why t is y over 2, we also know x is t squared minus 4. Yeah. Can I substitute this in here? Boleh kan? I can substitute the t into x. Yeah. Yeah, I can substitute this in here. So if I substitute it in there, x will be equals to y over 2 squared minus 4. So x equals to y squared over 4 minus 4. So that means for x equals to y squared minus 16. Rearrange everything. You will get y squared equals to 4x plus 16. Okay. So you arrange this, you get y squared equals to 4x plus 16. Okay. So to answer this question, okay, so to do it using the second method, yeah, so to do it using the second method, you need to be able to recognize functions. So which is why earlier I say that for you to be successful in this topic, you need to be able to recognize. If I give you this, you need to know it looks like that. If I give you this, you need to know it looks like that. Okay? Things like that. All right? So in this question, what do you think it looks like?
Linear equation.
Yeah. It's x equals to this. So you can look at it like this. It's almost like that. It's almost like that. Yeah, it's almost like that. What is that? Yeah, what is this? So previously we have x equals to y. Sorry, so previously y equals to x squared. We know it's u. Y equals to negative x squared is like an n. What if it's x equals to y squared? What does it look like?
C.
C kan? Yeah. X equals to negative y squared. Reverse C kan? Yeah. So, okay. So you know that basically this, the relationship is roughly this. So it's going to be some sort of a C. It's going to be some sort of a C. Okay. It's going to be some sort of a C. So what you do then, you just have to plot 2 points. You know from your interval, you start from -1 kan? And you finish at 2 kan? So you only have to get the points for 2. You only have to get 2 points. The starting point, the initial point, and the terminal point. So we calculated this earlier. This is -3, -2, 0, 4. Okay. So what you do then is you have the starting point, you have the initial point, you have the terminal point. You can plot this. On your graph as well. Okay, so you know your initial point is salah kah? Betul, -3 and -2. So you know -3, -2 somewhere there. Okay, so you know that's initial point, and you know your endpoint is 0, 4. So 0, 4 is going to be up there somewhere. So that's your terminal point. Okay, so you need to get the starting point. So you need to get the initial point and terminal point saja. So now I have the two. Okay, I have the terminal point and initial point. So the only problem now is how do you join these two lines together? You join using a straight line kah or what? You join using a straight line kah or what? No. Because you know that the function looks like a C. Yeah, you know the function looks like a C. So you join it using a C lah. Yeah, you join it using a C. So then, you know, this is initial, this is terminal. That means the arrow is going that way. Then finish. Okay, so that's the second method. Understand this? Do you understand the second method? Everyone?
Yes, doctor.
Understandable.
Yes, doctor.
Okay. So in test and exam, you can use either method. Okay, you can use either method. But sometimes I will ask you to actually do the conversion. I will ask you to do this conversion sometimes. Then I will ask you to do this conversion. Convert both parametric equation to x and y function. That means if I ask you to do that, that means you don't have a choice. You have to do this method. Okay. All right. Okay. So let's go through one more question quickly before I end the class. We end roughly 9:30. Okay. One last question. Okay. So x equals to square root t. Y is equals to t. And then the interval is this. Okay, so sometimes I write the interval in this manner, so it equals, yeah, I equals to this. Okay, so sometimes I'm going to present the interval in this fashion, but what it actually it actually means the same thing lah. So what it basically means is this lah. Okay, so don't get shocked. So don't get shocked if you see me presenting something like this, the interval in this fashion. It basically means t goes from 0 to infinity. Okay, t goes from 0 to infinity. All right. So for this question, I'm going to force you to convert. Okay. Well, in a way, you are forced to convert because you don't have a fixed number for your infinity. Yeah, you don't have a fixed number for your infinity. So you can't if you want to use the table form, if you want to use the table punya method of solution, you have to go from 0, 1, 2, 3, 4 all the way to infinity. Okay. So in a way, you are being forced to convert first. Okay. So convert. Okay, so first question, convert the parametric equations above to x and y function, as well as and removing the t at the same time. Okay, so that's the first question. Second question, plot the function. Okay, just plot the function. Okay. Okay, so how do you answer the first question? Okay, so now let's answer the first question. How do you convert? Okay, this one's simple. X is equals to square root t, y is equals to t. So you know y equals to t sudah. No need to rearrange this equation. You can straight away substitute into the x one. Yeah. So substitute into your x function. So x is equals to square root t, y is equals to t. So if I substitute this into x, I get x is equals to square root y, right? Correct. So what is y? Y is x squared. Agree? Agree?
Yes.
Yes, doctor.
So when y is equals to x squared, in this instance, what is the c? What is the plus c? Tiada kan? What is the plus c here? Tiada kan? That means it's actually 0 lah, plus 0. Okay. So what does the graph look? So what does this function look like? What is the shape? With y-intercept of 0. It's basically this. Okay. Let me draw it more accurately. It has to touch the 0 point there. Okay. Yeah, it's like that. Okay. Now, have I finished the question? Yeah. So I converted. I sort of plotted, but haven't finished. Yeah. So I plot the function, but is it finished? Not finished, right? Because no direction, no initial and terminal points. Yeah. So it's not quite finished yet. Okay. So how are you gonna get the how are you gonna get the starting point? Well, you substitute lah. So you know your t starts from 0 to infinity. So your 0 is the initial point. So when t is equal to 0, y is x, y is y. Y is x. Anyone? When t is 0, y is x, y is y. Quick. Quick, everyone participate. Otherwise, if everyone keeps quiet, then I'm going to turn this into face-to-face class.
0.
Yeah, 0. Y is y?
0.
Okay, good. Okay. So you know your initial point is 0, 0. What is it?
0.
Yeah. Okay, good. Thank you. Okay, so your initial point is there, 0, 0. Okay, next. Where is the terminal point? Well, terminal point is infinity. Okay, terminal point is infinity. So actually, there's no terminal point. Okay, so in this question, there's no terminal point because it's infinity. It's never ending. Okay, so you cannot get terminal point, but you still need to give me a direction. You still need to give me a direction. Is it going this way? Is it going that way? Which way?
Right.
Right or left?
Right. Right
What?
way.
Okay, correct. But why?
Because the infinity is
Because
positive.
Yeah, because
yes.
your infinity bukan negative. Your infinity is positive infinity. Yeah. So if you don't believe me, you choose any positive number. You just choose any positive t. Yeah. You choose any positive t. Try maybe positive 10. Okay, I try positive 10. No. There's a square root. There's a square root. I try positive 25. Or 16 or 16. I try positive 16. Okay. If it's positive 16, then it's what? Then what is x? Why is it? Why? Right. 16, right?
Yes.
Yes. 16.
Yeah. Okay. So where is 416? On the left hand side or on the right hand side?
Right hand side.
Yeah, right hand side kan. 4 will be somewhere here. 16 will be somewhere up there. So I don't know, maybe it's a point somewhere there. Okay. So no matter what number you put in for t, no matter what what number you put in for t, it's always going to be positive. So it's always going to be on the right hand side. So what that means is actually then you don't have the left hand side in your line. You only have right hand side in your line. Okay. So this is to denote infinity. Okay, so that finish. Okay. So you have to delete the left hand side in your line because it doesn't exist, because you start from the initial point 0 0 there and you go right. There's nothing going left. So left hand side you gonna delete. Is that clear?
Clear.
Yes.
Okay, so that's clear. Okay. Gonna end the class here today, but wait, don't go anywhere. Don't go anywhere. Stay for a while. I will share the attendance link here. Yeah, so you wait for me. Hmm? Okay. We are session semester 2, 2023, 2024, right? Okay, done. So how do I do attendance? Attendance here. 8 o'clock, 25th. Okay, that's slots. Okay, so link. Okay, so you have, okay. So I'm going to share with you the link now. You look at the chat box. Look at the chat box. Link is going to be in the chat box. now. Okay. Okay, so I've shared the attendance link in the chat box. Make sure you do it by 10 o'clock. The link will expire at 10. All right. Make sure you do it at 10 by 10 o'clock. All right. Okay, so I will see you Friday. Friday online, huh? Okay, Friday will be online.
Sir,
Yep.
I have a question.
Yep, sure.
So you said that you won't share the note that you did in lecture, right? So there will
Yeah.
be no notes at all.
Yeah.
So we won't have any lecture notes at all.
No, lecture notes will be the notes that you take by yourself.
Okay, sir. Thank you.
Okay. Yep. Yep, go on. Yeah. So yes, reference book will be what reference book did you use for calculus 1? Thomas ka?
Yeah.
First calculus? Okay. Yeah. You can use that book or you can use Thomas calculus, but for people who's attended my course before or for repeat students, you will know that you don't actually have to refer to anything. You follow my class, you understand what I'm talking about. As long as you follow my class, you understand all the examples, you will do very well. You can refer to the reference book, no problem. Okay. You can use First Calculus Guide, you can use Thomas Calculus Guide, no problem. Okay. Those you can use any of those two reference books. Okay. But the most important thing is you attend my class, and the second most important thing is you understand what I'm telling you. You understand what I'm talking about. Okay. That will be enough, actually. Okay, so I will leave the link here for people to do attendance. Okay, once you've done attendance, you can leave. All right. Okay, so I'll see you Friday.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you,
Thank you, doctor.
Thank you, doctor.